it was equal masses anyways.
Mm-hmm.
That was my logic at least, and I solved it to get 46.67 degrees Celsius.
Okay, so
So I rounded it off to 50.
uh, we'll have to check what mistake you're doing. Let me tell you the solution and then please cross check. So you have on one hand water and you have paraffin, and the temperatures are different, 80 degrees and 20 degrees Celsius. What is given is the mass of the two substances are the same, and the specific heat of water is twice that of paraffin. So let's say water is 2C and let's say paraffin is C. These are specific heats. So we have to find out what is the final temperature of the mixture. So this happens when the system reaches the steady state. That means the temperature will remain constant for the final mixture. So basically what will happen is water will lose energy so that its temperature drops down from 80 to T, and paraffin on the other hand will gain heat energy so that it increases its temperature from 20 to T degrees Celsius. So basically what you have to do is the heat lost by water, we need to equate this to the heat gained by the paraffin molecule. Alright, so the heat is given by mass into specific heat into temperature difference. Now mass is the same for both, so on both sides I can write m. Now for specific heat, 2C is for water and C is just for your paraffin. Now delta T in case of water will be 80 minus T, and in case of paraffin the temperature difference delta T will be T minus 20. So now you can see the M and C can get cancelled out from both the sides. So you will have an equation like this: 2 times 80 minus T, that will give us T minus 20. So on solving this, 160 minus 2T, this is equal to T minus 20. So 180 will give you 3T, and temperature then comes out to be 60 degrees Celsius. Now Sheldon, please check where was the mistake which you were doing.
Oh, yeah, sir. Let me just double check real quick.
So can you tell me where did you go wrong?
It's actually very difficult. Can I send you my working instead?
Okay, so later on please
Yeah,
send it to me. Okay,
yeah.
let's
I'll just write down this working real quick.
okay, so please write it down. Let me know when you finish. Okay, in the meantime, Somil, what's your answer to question number 4?
For 4, I got A.
Correct. So others, please also check if they got A, because that is the right answer.
Yes, sir.
Yes, sir. Yeah. The A1.
I'm done with my working, sir.
Okay, great. Did you solve question 4th?
No, sir.
Okay, Vaibhav, could you tell us your approach? How did you get 1 by 2?
Um, I mean, if you look at so like basically one atom of helium 4 would give us 4 grams, and
Hmm.
one atom argon would give us 40 grams due to um,
Correct.
the atomic mass of it, and then you can just calculate it. It's 1/2.
Okay, Vaibhav, just a second. You said one atom of helium is 4 grams.
Yeah. No,
Repeat.
I mean that's the like in four in wait, yeah, that's what I said. Yeah.
No, no, one atom of helium doesn't weigh 4 grams.
No, no,
So,
no. I didn't mean that. I mean the molar mass of it is 4.
yes, correct. So, the molar mass, so 1 mole of helium weighs 4 grams. Okay, so
Yeah,
never mind. Proceed after this.
yeah, and then 1 molar mass of argon is 40
40
grams.
grams.
Yeah, and then you have 40 grams of argon, so that's 1, and then 8 grams of helium, so that'll be 2. So it's 1/2.
Yes, good. Okay. So, Sheldon, you should pay attention here. So, it's given 1 mole of helium is 4 grams. Here it is represented by this, the 4. This is the molar mass. So, what is given to you is 8 grams of helium. that means the number of moles of helium which you have is 2, which comes out from here, 8 by 4. Similarly, if I consider argon, now its molar mass is 40 and 40 grams itself is given to you, which means the number of moles of argon will be 1. So if I find the number of moles ratio, argon divided by helium, we will get 1 by 2. Now basically the number of atoms for a particular substance is directly proportional to the number of moles, which means the number of atoms ratio for argon and helium, this ratio will be equal to the number of moles ratio, which we have found out as 1 by 2, and which means your answer is option number A.
Got it, sir.
Okay, next is question 5. Okay, this is interesting. Saumil, what's your answer?
So I got A.
Okay, Ayush?
So even I wrote A.
Alright, so A is actually the correct answer. So everyone please check if they got A. Smera, Vaibhav, Sheldon?
Yes.
Yes, sir.
Okay, Vaibhav?
Yeah, I said so. Yeah.
Okay, Sheldon, did you solve this?
Yes, sir. I did as A due to Boyle's law.
Could you tell us the approach?
So the graph of Boyle's law actually states that T would be constant. Oh wait, I realized. Okay, wait, I got really confused. Boyle's law for a graph is very similar to C, and I correlated it with that.
No,
Yeah,
Boyle's law
I figured out my mistake.
Sheldon, Boyle's law is not relevant here. So Boyle's law states this: pressure is inversely proportional to volume. So if you have a graph which has pressure as the y-axis, volume as the x-axis, so if you see this is what is the Boyle's law. In this case, we have to find the internal energy. Saumil, could you tell your approach?
So the keyword in the question that it is the system is thermally insulated from its surroundings means that there will be no energy coming into the system and nothing will be going out of the system. It will be just an exchange between the ice and water, so it will remain constant.
Absolutely. Sheldon, did you understand the approach? What Saumil just said?
Yeah, somewhat so.
Since the system is thermally insulated, this means no energy can come in and no energy can go out. Whatever is happening is within the system. So if you, again, there is one more keyword which you have to focus on. Which graph best shows the variation of total energy of the system? So this is the keyword here. Since your system is isolated, hence the the internal energy of the system, that will remain constant, and a constant graph is only present for option A. Sheldon, understood?
Yes, sir.
So just remember this: thermally insulated means the energy transfer is 0, which means the energy will remain constant if you are focusing on the whole system. Okay, now let's move on to the next question, 6th. All right, Smera, please tell me your answer.
Sir, I got B.
Good. Ayush, what's your answer?
So I didn't get this one.
All right. Vaibhav, did you solve this?
Yeah, I solved it, but I got C, so I didn't get it.
Okay, so could you tell me your approach? Let's check.
I mean, I used first the I used the specific rate of vaporization of the formula Q equals ml.
Mm-hmm.
And then based on that, we know the mass and we know the latent heat of vaporization for it.
Correct. Okay.
And then based on that, you could find the if you just substitute it, you can find the
Okay, so let me substitute the values. 0.6 multiplied by 200 kilojoules per kg. So this will be how much?
It should be 120. So
Yes. So anyways, what after this?
Yeah, after this, I got a bit confused because um there's a phase change happening in work done would equal uh like I didn't understand what
Okay,
happened.
no issues.
I guessed 4,800. I didn't get this.
Okay, actually the right answer is B. What Smera just said. Somil, did you get B?
Yeah, sir, B.
Okay, Ayush.
No, sir, I didn't get this one.
Oh, you didn't. Okay, so Smera, could just tell me your approach. How did you get 3000?
Yes, sir. So, the energy is equal to energy needed for vaporizing it would be equal to M into LV. So, energy I found out is 0.6 into 200 kilojoules. So, and after that, I divided it by 40 seconds, as that is the time taken for the vaporization to be completed
Okay,
to
great.
find out the power of the heater.
Good. So basically what we are doing here is, so you have a heater and the power of it is constant. So that power is what we need to find. Since the power is constant, we can consider any portion of the graph, it will give you the same answer. So let's say if I focus on the part whose values are given to you. Now it's given that latent heat of vaporization of the substance is given. This means this is the phase change is happening here. So that is represented by the horizontal line. So from A to B is your phase change where your latent heat of vaporization is being acted upon. So if I focus just on AB, so the heat energy Weber, which you found out from MLV, this is the heat energy during the process AB, during the phase change QAB. Now since we are supposed to find the power, that is nothing but energy per unit time. Energy you found out as 12 1 so 1 2 3 4, so 4 zeros, 1.2 lakhs, and we divide that by the time taken. Now the time taken will be this between A to B, so that will be 50 minus 10, so that will be 40 seconds. So that is the total time taken. So if I substitute here, so now just check, so you will get 3000 watts as your answer. Ayush, Vaibhav, did you understand the approach?
Yeah, sir.
So
I
please
understood.
write down the solution.
Yeah.
Yeah.
Soumil, did you use some other approach or this was it?
Same approach, sir.
Okay, great. Sheldon?
Done.
Yes, sir.
Alright. So Sheldon, are you done writing?
yes, sir.
Okay, question number 7. Soumil, please tell me your answer.
So I got D for Delhi.
Alright. Vaibhav?
Same, sir. D.
Yes, so D is the correct answer indeed. So Ayush, did you get D?
I wrote B.
You got B. Alright, let's check. Smera, what about you?
Sir, I wrote B. I was not sure about this question.
Okay. Sheldon, did you solve this?
Yes, sir. I had taken this as A.
Okay, so let's check. So since Soumil, you have got the right answer, could you tell me the logic?
So I actually don't know the logic behind why it is divided by L, but I actually just played around with the units, that's all.
That's wonderful. So that is a good approach. So tell that also, the approach.
So the first two options are clearly eliminated because the formula is number of moles into RT and not number of molecules into RT. It's supposed to be number of molecules into KT, so it's only C and D. And then what I did was, since pressure is Newton per meter square and since PV is equal to NKT and pressure is Newton per meter square and volume is meter cube, So the unit becomes Newton meter.
Okay.
And since force is in newtons, you have to divide the NKT by something which has the unit of meters. So that's option D.
Okay, Somil, that's a wonderful approach using units. So even if you do not know the actual method, you will get the right answer. So anyways, let me tell you the method which is supposed to be used if you do not know the units method. So Vaibhav, how did you solve this?
Yeah, so I actually took a bunch of um, like I equated P and P is equal to F over A,
Mm-hmm.
and then I got force is equal to pressure into area.
Yes.
Then we know that P is equal to we can take it as NKBT over V,
Correct. Correct.
and then we can multiply that. And since we know the volume of the cylinder would be A into L, like
Mm-hmm.
the length of it,
Yes.
we can cancel A, and then you can get NKBT over L.
Correct. So that is the what I'm about to explain. So the method goes like this. Let's say if I start with the ideal gas, which is PV is equal to nRT. Now we have to find the force acting. So the only variable which has force in it is pressure. Pressure is nothing but force per unit area, and we write V is equal to nRT. Now volume will be area multiplied by the length L. So area will get cancelled out. On the left hand side you will get only force multiplied by the length. This is because the volume is area multiplied by the length. Now this will be equal to nRT. So let's try to isolate this force variable. That will give us nRT divided by L. Now let's check if this matches with any of the options. So there is no option which matches here. So because N here stands for the number of moles, and what is given to you is the molecules. So we have to play around accordingly. So we have to convert N into the number of molecules. Now for that we have to remember this relation, the Boltzmann constant Kb. If you observe the options C and D, it has a Kb, that is the Boltzmann constant, and this is given by this formula, R divided by Na. Na is the Avogadro's number and R is your gas constant. So if I use R as Kb times Na and put in this expression, so that will be N multiplied by R will be written as Kb times Na, then you have the temperature T divided by L. Now if so basically 1 mole of any substance will have Avogadro number of molecules. So let's say if there are n moles, so it will have n times Na molecules. So this is the number of molecules, and this is given to you in the question as capital N. So n times Na can be written as capital N, and the rest of the terms can be put as it is, Kb by L. So now if you can check, this is option number D, NKT by L. So please write down the solution for this. Somil, you need to be aware of the actual method as well, so please write down this solution.
Yes, I actually had written it till force upon area into V is equal to nRT, but after that I didn't think of V as L into A, so that's why I cancelled that method and did this.
Okay, anyways, the units approach was great. Good. Sheldon, did you write down the method?
I'm writing it down as we speak, sir.
Okay, no problem. So let me know whenever you finish.
Done, sir.
Great. In the meantime, Ayush, did you solve the next question, 8th?
Yes, sir.
What is your answer?
So I wrote my answer as A,
Oh, is
but I was confused between A and B though.
okay. So please cross check again. What
Yeah.
would be the answer? Vaibhav, what is your answer to the next question, 8th?
Sir, I got B.
Great.
You.
Okay. Somil,
Yes, sir, B for Bombay.
Smera, did you get B?
Yes, sir.
Okay. Sheldon, are you done writing the solution?
Yes, sir. I'm done writing the solution.
Okay, did you by any chance solve the next question?
Yes.